project is automated detection of lung lesions in computer tomography images. We take a set of images, we then use image processing on that, so we remove all the external structures except for the lungs, then we analyse the lungs and we try and find the cancer within that lung. Using our program here, we're hopefully able to speed up the process. Instead of having to look at 100 images, let's say, they could look at 10 and go, okay, these are the ones we need to look at, this is where we have our issues, and then get patients onto the correct treatment.
This project came through my IBL at the Royal Children's Hospital in clinical technology, and in that team we look after medical equipment across the paediatric intensive care unit, and I saw that there was a need for a new device as the current one was reaching end of life. So there's three main components to my project. The display screen, which shows what the pressure is and displays the thresholds. The pressure sensor, which obviously measures the pressure and then sends it to a microcontroller and control board, which does all the logic and kind of the smarts of the device. Also, there's some LED lights and a speaker for alarms. By redesigning this device, it's a lot easier for the user to interface with it. In the future, we're hoping to create a second prototype and develop this device further. And as well as these tracheostomy patients in the Royal Children's, hopefully it might be useful for sleep apnea patients as well.
So this project was for the National Instruments Autonomous Robot Competition. The robot that we designed uses a laser sensor to measure the distances, and then we can take that and generate a map of it, and from that map we can navigate between points and figure out where we need to go. Some of the benefits of mankind from this technology would be increased productivity in farming. So this is actually a farming application. It's designed to actually increase productivity, increase output, and minimise the amount of physical labour that humans have to do while enabling them to complete their jobs.
My project utilises the Connect sensor to allow people to interact with more complex systems. And Picasso, which is on display, is a way to get user feedback on these complex systems. And as we progress that idea further, we have the Da Vinci project, where we're using a robot arm and we're controlling that robot arm with the Connect sensor. So as you move your arm, the robot arm moves with you. Such applications for this project is rehabilitation and assisting people in overcoming their fine motor control difficulties or disabilities.
The reason that I picked Swinburne was because of the industry-based learning year. I did my IBL through Monash Medical Centre. It was a really good experience, and I got to work with a really good team, and it definitely helped develop my technical skills and was one of the key factors that got me my job at the Royal Children's Hospital.
Swinburne is really focused on industry partnerships, and it really encourages hands-on action in the projects. For example, every year of the mechatronics and robotics degree, we are able to build robots from scratch in a team environment.
I feel prepared because I've actually had the opportunity to do a lot of practical work. For example, this robotics competition, I got to develop a robot from scratch and experience the whole project workflow from start to finish.
When I came to Open Day in 2009 at Swinburne, I fell in love with the place. It's a really warm atmosphere, the people are really friendly. There's small class sizes, so you actually get to know the lecturers and have a personal relationship. They know your name, you're not just someone in a lecture theatre.
Swinburne is a great place to study.